Welcome to the Advanced UHPLC Pump Troubleshooting webinar. Today's objective is to give you more knowledge about how to approach the pump troubleshooting. Today's agenda. First, we will tell you more about the UHPLC pump technology, how it works. Then, we will discuss 3 troubleshooting cases. We will provide you a troubleshooting recommendation list. And we will continue with a question and answering session. Troubleshooting on the pump, it's required to have a tooling available. This toolkit contains a torque wrench, a seal replacement tool, a crawl foot, 3 Allen keys, a hex bit, and a socket wrench of 1/2 inch. Here we have a troubleshooting checklist. Of course, all the lines are important, but we highlight 2 of them. Check all connections for loosened fittings. And please verify if the check valves are installed with the correct torque setting. The torque on the check valves should be set to 8 Newton meters. If you tighten up the check valves more than 8 Newton meters, it might be that you will damage the check valves. If you tighten them too loose, they may start to leak. So please make sure you tighten up the check valves with the torque wrench up to 8 Newton meters. Now we will continue with explaining how the UHPLC pump technology works. Pump contains 4 pump heads. 2 pump heads for pump A and 2 pump heads for pump B. With this you have a gradient set. Both pumps are connected to the purge valve. Each pump has a primary pump head and a secondary pump head. Pump B has exactly the same configuration, a primary pump head and a secondary pump head. The primary pump head contains 2 check valves, one inlet check valve and one outlet check valve. The secondary pump head doesn't contain any check valve. Inside those check valves there's a cartridge. The cartridge is equal for both check valves, the in as well as the outlet. Please note, on the cartridge there's an arrow. This arrow is facing in the direction of the flow. It should always face upwards into the flow direction. Each pump head contains a piston. The piston for each pump head is exactly the same dimension. Now we will focus on one pump set only, so pump A, because pump B is exactly the same as pump A. We will go a little bit deeper into the technology. As you can see, the primary piston filled the mobile phase into the primary pump head and it's waiting. The mobile phase is colored dark blue. The pressure inside the primary pump head is 6 bar below the system pressure. The system pressure is at the secondary pump head, as well as on the purge valve. The reason why the primary pump head is 6 bar below the system pressure is because we want to ensure that the outlet check valve is closed at all times. Both inlet and outlet check valves are closed. The secondary piston is delivering its system flow rate. Please mark the white dot in the flow path. This will move along to your LC column. The secondary piston is pushing the flow rate towards the LC column, and it's emptying the secondary pump head. Now the primary pump head will move forward. Moving the primary pump head piston forward will increase the pressure in the primary pump head. The outlet check valve will open. The primary piston will now refill the secondary pump head. At the same time, the primary pump head will also deliver the system flow rate. The primary pump head is now empty, and it will refill. The secondary pump head is ready to deliver its system flow rate again. The outlet check valve will close, and the inlet check valve to aspirate the mobile phase will open. The pressure inside the primary pump head will drop into ambient pressure. The secondary pump head will deliver its flow rate. The pressure inside the primary pump head is now ambient pressure. Therefore, the color in this pump head is lightning blue. Now the primary pump head is filled with mobile phase. The piston will move forward. The pressure inside the primary pump head will increase up to 6 bar below the system pressure. During this session of increasing pressure, it will calculate its compressibility value. This is based to the distance which it takes to get below the 6 bar below system pressure. Yeah? There's the distance and the time. The inlet and the outlet check valve are closed. This is the advanced pressure view available in the maintenance screen as well as the service mode. In this screen, you will see 4 pressure sensors, which are installed on the pump heads. You will also notice that system pressure on both pumps, pump A and pump B, are almost similar. You will also observe that the primary pump head, the pressure on it is 6 bar, approximately 6 bar, below the system pressure. And that's for both pumps. During the loading stroke of the primary pump head, the green bar will drop. The system pressure is stable. You will also notice that there's a compressibility calculated in here. Because the values of compressibility are almost equal, we can assume that the mobile phase inside both pumps is similar. The pump is running for 50-50%, 50% A, 50% B, at a flow of 500 microliters per minute. We will continue with the cases. Each case is based on a certain structure. First, we will check our observations, the end user made and the engineer. Then we will collect information from maintenance mode, service mode, from the pressure graph and the advanced pressure view. After that, we will exclude parts which are probably not related to the source of the issue. Then we will start to clean the pump or even replace suspected parts. First case. The end user made the following observations. There are pressure dips during analysis, as you can see in here, and we also see shifting retention times. The system also pops up with a compressibility error. Those errors are generated in numbers 778 or 779. We gather information. We start running the pump for 100% A. We observe pressure fluctuations on 100% A, as you can see in the pressure graph, which is available in the maintenance screen. You can see the pressure dips in here. If we run 100% B, there are no pressure dips. It's a complete flatliner. So we suspect pump A to be the source of the issue. Secondly, we will run the pump for 50-50% AB. Running 50-50%, and we observe what the pressure is doing. We see that pump A cannot aspirate anything. We see pressure building up in the secondary pump head, but the pressure on the secondary pump heads will only be generated by pump number B. Pump A doesn't do anything. It's not aspirating anything. As you can see, the pump is also pumping up with an error message, compressibility error 778, which is based on the compressibility error on pump number A. We will continue with pumping 100% B and see what's happening. So it's building up pressure. The primary is 6 bar below the secondary. It's refilling it correctly. It's generating also a compressibility factor. So pump B is good. Let's see what pump A is doing. So pump A is loading. It is 6 bar below the system pressure, generating compressibility. Oh, it's dropping really. Oh, this is not good. You see, compressibility is going all over the place. No, it's not good. No. Pump A is suspected to be the source of the problem. It's not aspirating any mobile phase. The location of the source of the problem is the inlet check valve. Before replacing any parts on the pump, we follow the next steps. We are going to flush the pump for 30 minutes using 100% IPA with a back pressure of at least 200 bars. After that, we will check the pump's performance. If the flushing didn't help, we will replace the inlet check valve of pump A. We continue with the second case. The customer observes pressure dips during the gradient, as well as retention time shifting. We gather information. We run the pump for 100% A and we run the pump for 100% B. First 100% A. Let's see what's happening. We see pressure dips during this flow action. And this is not good. There's definitely something wrong with pump number A. Let's see how pump B is doing. So we are now at 100% B. Now this is nice and stable. Huh? So this is good. So B is good. The problem is A. Let's see what's doing when we do 50-50 and how the pressure sensors which are installed and integrated into all 4 pump heads are giving an actual pressure. Running 50-50% AB. This is the pump pressure, the system pressure. Here we see that the primary pump head is 6 bar below the secondary pump head, but we also notice that the primary pump head of pump A is exactly the same as the system pressure. That's not good. That's not good. This means that the system pressure is transformed to the primary pump head. Actually, this check valve should be closed. The outlet check valve should be closed. This should be 6 bar below the system pressure, right? and it's even not calculating any compressibility. The problem is in pump A. Let's see what it's doing when we do 100% B. Loading fresh mobile phase. Let's see. It's a small stroke. 6 bar below system pressure. And this is good, giving a compressibility factor. So this is good. Pump B is good. Let's see what pump A is doing. So increasing the pressure. But still, this is strange. Huh? This is not good. It's not even calculating compressibility. It cannot, because probably the outlet check valve is continuously opened. Yeah, the source of the problem is the outlet check valve. Definitely. The outlet check valve is located in here. We are not going to replace it directly. First, we will flush the pump for 30 minutes using 100% IPA, using a back pressure device of at least 200 bar. We check the pump performance after these 30 minutes. If the pump performance is okay, you can leave it this way. If not, we still are going to replace the outlet check valve of pump A. Case 3. The customer observes that the system pressure is lower than the analysis results he got before. He also noticed that the retention times are different. We gather information. In the advanced pressure view, we check for 50-50% AB how the pressure looks like and how the loading strokes of the primary pump pads are. Well, we see a stable pressure, system pressure. We also notice that the primary pump pads are 6 bar below the system pressure. The loading steps are doing fine. We see a compressibility value, both similar, and we pump with mobile phase. Pump A, pump B are equal. So the pump is running fine in this screen. So that also means that the check valves, the inlet and the outlet check valves are okay. I'm convinced about that. What we also noticed in the pressure view in service mode, there's a leakage value in here. This leakage value is a value for checking the primary high pressure seal. Primary pump head high pressure seal. So this is good. Well, we always say that typically this should be less than 5 microliters per minute. Actually, it doesn't matter. how much this value is, because the primary pump head will only work a little bit harder to refill the secondary pump head, because that's what it's doing. Yeah, but anyway, these are very good results. So there's nothing wrong with the primary high pressure seals. We will check the flow rate according to the instruction in the service manual, flow accuracy check. We will do that for pump A as well as pump B at the flow rate of 200 microliters per minute and 1 ml. We observe that pump B is doing fine. The results of this flow rate check is good, within specifications. On pump A, we have deviation. It should be better than plus minus 10 microliters. So pump A is suspected to be the source of the problem. We suspect the high pressure seal in the secondary pump head of pump A. We will replace this high pressure seal. After replacing the high pressure seal on pump A on the secondary pump head, we will condition a pump using 100% IPA with a back pressure of at least 200 bars for 10 minutes. After this conditioning step, we will check the pump performance. We would like to provide you some general recommendations. Please flush the pump for 30 minutes using 100% of IPA with a back pressure of at least 200 bars. This will actively clean the check valves. It will get rid of any contamination inside the pump flow path, like bacterial growth and particles. We recommend to flush this on a weekly basis. Please watch our service instructions, which are available on our Spark Holland YouTube channel. Hereby the take-home message from this webinar. Step 1. Try to reproduce the observation the end user made. Gather information from both channels using the advanced pressure view, the pressure graph, and service mode. Eliminate parts which are not part of the issue. Use the cleaning procedure or replace suspected parts only. Check the pump performance after the repair.